All right, good to see you guys. Today will be our last unit on transformations. I want to teach you the final transformation. We've dealt with a translation, which is a shift. We've dealt with a reflection, which is a flip. We've dealt with a rotation. And today we're going to learn about a dilation, which makes something big or small. And then with that, we're going to deal with what's called a composition of functions, where you've got all of these potentially involved in one transformation. You could have a slide followed by a flip and that kind of thing. But first, let's deal with a dilation. We're asked to take this triangle. I'll go ahead and mark it A, B, and C. And I want to dilate it by 1/4. Now, don't worry about where it says the center is 0, 0. Now, I noticed that the axes weren't super obvious, so I'm going to go ahead and mark these. All right, what we've got to do is we've got to find the ordered pair of the existing. So for instance, this is 1, 2, 3, 4, 5, 1, 2, 3, 4. So that's at 5, 4. A is at -1, 2, 3, -1, -3, -1. And C is at 1, 2, 3, 4, 1, 2, 3, 4. So that's 4, 4. Okay, now the way these dilations work, for instance, let's say you've got a point X and it's -5, 3. Now, if you want to dilate it by, say, a factor of 3, you're going to do 3 times that ordered pair. So 3 times -5 would be -15. 3 times 3 would be 9. And so that's how you would dilate just a point, an ordered pair. Or let's say we had Y, and I'll make this easy on me, that you wanted to dilate it by 1/2. In other words, you're making it smaller. Well, you do 1/2 times 6, 2, which would give you the ordered pair 3, 1. So that's what we're going to do here. We're going to take each of these ordered pairs, multiply it by 1/4. And so I think I'll use a different color marker at this point. So let's take point A, which is -3, -1. We're going to multiply it by 1/4. And so that'll give us the ordered pair -3 over 4, -1 over 4. Now, on your notes, you're just going to have to estimate where that ordered pair is, but I'll go ahead and do it here. So -3/4 would be about right here. -1/4 would be about right here. So that will be A prime. All right, now we take the existing B point, that ordered pair, 5, 4. We hit it with a multiplier of 1/4. Let's see, what am I doing? Oh yes, there we go. And so that gives us the ordered pair 5 over 4 and 4 over 4, which is the number 1. Okay, now 5/4 is 1 1/4, so I'm going to go over 1 and then a little bit more, and then up 1, and that will be B prime. And then with point C, similarly, we're going to hit, this will be easy because will multiply nicely, 1/4 times that ordered pair. And so that's going to give us the ordered pair 1, 1. What? That can't be right. Have I messed up here somewhere? Oh, yeah. This is -4. Yeah, that would help, wouldn't it? Okay. So let's go here. So 1, -1. All right, so 1, -1. So that will be C prime. And there you have it. You've got the triangle that was reduced, dilated. This is called, if it gets bigger, it's called an enlargement. If it gets smaller, it's called a reduction. And let's do that second one also, just for the heck of it. And let's see, where am I going over here? All right, so the previous one was a reduction. This is going to be an enlargement because we're dilating it by a factor of 2. It's going to be twice as big. All right, first thing to do is to establish the correct ordered pairs. Let's just go ahead and name it A, B, and C. And this A is -1, 1, 2, 3, 4. So it's -1, 4. B is -1, 2, 3, 0. And C is 1, -2. Okay, now we take each ordered pair, multiply it, in this case, by 2, and we've got our new ordered pairs. So if point A started off at -1, 4, and then we multiply it by the number 2, we've got our new ordered pairs at -2, 8. So let's use a different color and let's find -2, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yay, it worked. I hate when there's not enough room on these worksheets they give you. So let's go with point B now. Point B is at -3, 0. We hit it by a factor of 2. And we get the ordered pair -6, 0. So let's find that. -6, 1, 2, 3, 4, 5, 6. Well, I shouldn't have put that one there, but I did. So that'll be B prime. And then C is at 1, -2. And so we hit that with a factor of 2. 2 times 1 is 2. 2 times -2 is -4. So C prime then would be at 2, -4. 1, 2, 3, 4. And we've got a triangle that's twice as large. And I'm wondering if I messed up again on this thing. Yeah, I did. This is, oh, for crying out loud. This is 1, -1, 2, 3, 4, 5. Oh, for Pete's sakes. I didn't count right when I was marking it off. All right, so make that -5, -5, and so that's going to be -10. Yeah, that looks better. So we got 2, -10. Where's my origin? There it is. That's 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so that's the C prime. That's where C prime should be. And yeah, that looks a little bit more like it should be. All right, but here's the point. Remember, I've been talking about an isometry. Is a dilation an isometry? In other words, when you start with a pre-image and you enlarge it or reduce it and you get the image, is it congruent? Same size, same shape? Well, it will be the same shape, but not the same size. So the dilation is the only one that's not an isometry. And that one you need to keep in your head. All right, now let's go on to the topic of compositions. And let's see if I can find, I may have to go back over to my desk. Yeah, that's it, all right. Okie dokie. Now this is someone else's worksheet, but I liked it. I'm just going to do number 2 and number 3 with you. Hopefully you've got the notes printed out that you can follow along. Now, the notation here is a little bit different than what I've been using. Let's understand we're going to plot the pre-image, QRS, looks like a triangle. Then we're going to hit the transformations. The small r means we're going to rotate 90 degrees. Okay, now, this brings us to a good point. They haven't indicated whether it's clockwise or counterclockwise. If it's not said, it's understood to be counterclockwise, CCW. Then we're going to reflect it, the big R, we're going to reflect it across the y-axis. So we've got 2 transformations that are going here. And that's why you've got prime and then double prime. So the first thing we want to do is plot our point. I'll try to take my time with this so I don't mess it up like I did last time. So that's at 3, 3. All right, that's point Q. R is at -1, 4. 1, 2, 4. I like R because it's the pirate's favorite letter. And point S, 2, 6. 2, 1, 2, 3, 4, 5, 6. All right, so there's point S. QRS. So that's the pre-image. Now, the first transformation is we're going to rotate it 90 degrees. So, and this is the one, and we're going to go counterclockwise, so we're going to pretend that this page has been turned. And I always have a hard time with this. Okay, so if that, I'm looking at it as if I've turned the page 90 degrees this way, counterclockwise. I'm looking at Q, that's at -1, 2, 3, -3, 1, 2, 3. So I turn it back. I already forgot what I said. -3, 3. So go 1, 2, 3. 1, 2, 3. All right, so -3, 3. That's Q prime. Let's see. Okie dokie. Now, R, if I've turned this around, R, point R is at -1, 2, 3, -4, -1. And S, again, I'm looking as if I've turned the thing over, is at -1, 2, 3, 4, 5, 6, -6, 2. So -1, 2, 3, 4, 5, 6, -6, 2. All right. So that's the first motion. We've rotated it 90 degrees counterclockwise. Now the third one, this is why it's called a composition, because you're composing it of more than one transformation. So, and I already forgot to put what S was. What was S? -6, 2. Okay, now what's the next transformation? Well, here it says reflect this one. You don't go to the beginning. You go to the latest image, and we're going to reflect it over the y-axis. So this is our line of reflection right here. And so I'm going to flip, so get my microphone cord here. I'm going to flip this thing that way over that center line. Now, again, the way I do it is I just count to the left. All right, that's 1, 2, 3 to the left, so Q double prime will be 1, 2, 3 to the right. Okay, so that's actually where one of the original points was. Okay, now S prime is negative to the left, 1, 2, 3, 4, 5, 6. So I'm going to go to the right, 1, 2, 3, 4, 5, 6. So that's S double prime, and then R prime is negative 1, 2, 3. All right, so it's 1, 2, 3, 4 to the left, 1, 2, 3, 4 to the right. R double prime. And there is the final landing place. And I see that I forgot to put in my ordered pairs, but I'm too lazy to do it at this point. All right, let's do the next one, and then we'll be done with these notes. All right. Well, what's kind of nice about this, we're going to have 3 transformations here. And let's see what we're dealing with first. We got a 4-sided figure. Then we're going to reflect it, the big R, over the x equal 2 line. Then we're going to rotate it 180 degrees. Then we're going to translate it. Now this notation is different, but you can probably figure out what we're going to do. Once the translation, we're going to go left 10 and down 1. It's different than the notation we use in North Carolina, but that's fine. We can figure it out. Okay, so let's plot these points. 9, negative 3 would be right here, and that's point D. E is 6, negative 7. 1, 2, 3, 4, 5, 6, 7. Yep. All right, that was E. All right, F is at 3, negative 3. And point G is at 5, negative 1. All right, here is our pre-image. Now, we are going to do various transformations. We're going to do 3 of them. 1, 2, 3. All right, so the first one, to get to D prime, is we're going to reflect it over the x equal 2 line. Well, where is that? That's right here. That's the x equals 2 line. So F is 1 to the right. F prime will be right here, so that's 1, negative 3. I did F first. Sorry about that. All right, so that's F prime. G is 1, 2, 3 to the right, so G prime will be 1, 2, 3 to the left. So what is that? That's negative 1, negative 1. I want to make sure I get this right. Yeah, so far so good. All right, D is 1, 2, 3, 4, 5, 6 to the right. So 1, 2, 3, 4, 5, 6 to the left will be D prime. And that's the ordered pair negative 4, negative 3. And then E is 1, 2, 3, 4 to the right, so E prime will be 1, 2, 3, 4 to the left. And what do we got there? That looks to me like negative 2, negative 7. All right, so let's mark that guy out. And, you know, ask yourself, does that look about right? Well, no, it doesn't. Or does it? This is 1, 2, 3. Yeah, okay. My drawing wasn't too wonderful looking, but yeah, that's right. Okay, what's the next one? We've done this one. All right, now we need to rotate this thing 180 degrees. Again, we're not dealing with the preimage anymore. We're dealing with the prime one. Now we're going to rotate this 180 degrees. So this is where I have to get upside down here. Y'all can just turn your paper upside down, which I'm happy for you. All right, so if I'm looking at this thing upside down, G prime is over at 1, 1. So G double prime will be right here. All right, I'm looking at D prime, and that's at 1, 2, 3, 4, 1, 2, 3. So I'm going to go 4, 3. 1, 2, 3, 4, 1, 2, 3. All right, so that would be D double prime, and that's 4, 3. And let's see, what have I done? I need to do F. All right, so I'm looking upside down. F is at negative 1, 3. That was F prime, so negative 1, 1, 2, 3. F double prime. And E prime, looking at it upside down, is at 2, 1, 2, 3, 4, 5, 6, 7. Yeah, so it's 2, 7, turn it around. 2, 7. And that would be E double prime. Okie dokie. And we connect the dots. All right. So that's the second movement. Now the third, and let's double check to see what it was. Okay, we're going to translate this figure left 10 and down 1. So for instance, I'll just start up here with E double prime. E triple prime will be left 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then down 1. That will be E triple prime. And let's see, what ordered pair is that? That's at negative 8, 6. Okay, let's take F double prime and move to F triple prime. We go left 10 and down 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I had to cheat. Down 1. All right, so that's F triple prime, and that would be at negative 10, 2. Let's see. Let's go with D double prime. We go left 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and down 1. And this is D triple prime, and so that's at negative 6, 2. And then finally, which one have we not done? Oh, we haven't done G. So we go, from here we go left 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and down 1. So there's G triple prime. Oh, well, that was a lot of work. But this is the final image. And in some sense, they're all pre-images. But since we didn't use any dilations, this too is anisometry. All right, well, thanks for paying attention, guys.